All right, in this video, we're going to talk about the remaining two properties of exponents that we haven't talked about yet. In the previous video, we talked about zero powers, negative powers, product of powers, and quotient of powers. So if you haven't seen that video, make sure you guys go and check that out as well for the other four rules that are on the screen right now. The last two rules, I wanted to do them in a separate video because they kind of tie together a lot of the time, okay? So the fifth rule is referred to as power of a product. So again, we have that word product again. Remember, product is a fancy word of saying multiply. Okay. So what this rule is saying is that what happens when you take two numbers and you're multiplying them together, and then you apply a power to it. Okay. So here's the scenario: take two numbers. Let's just say x and y for right now. We're multiplying them together, right? X times y. What happens when then you take an exponent like m and you apply it? Okay. Well, what happens is that m, that power of m, applies to every single piece inside. Okay. So what happens is that once you write it out, the x gets its own power of m, and the y gets its own power of m. Okay. So the exponent that's on the outside applies to every individual piece on the inside, including like the whole numbers that are in, like sometimes in the front of the expression. Okay, so the outside exponent applies to each individual piece on the inside. Okay, as a quick example, if I were to give you this, 4x power of 3 y, and then I raise it to a power of 3. Okay, so what that's saying is that that outside exponent, that outside 3, has to be applied to every single piece on the inside. So it gets applied to the 4, gets it applied to the x power of 3, and gets applied to the y. So here's what it would look like. Okay, so the 4 gets its own power of 3. Okay, the next piece is going to be a little bit strange, but I want to put this in parentheses just to organize it clear. So that x power of 3 then gets another power of 3, gets its own. Okay, and then the y also gets its own power of 3. So every individual piece gets its own power of 3. That's what this rule is saying. Okay, now we'll come back to this in a second because I actually wanted to mention, like, this is actually the next rule. What happens when you have a power to a power? So we'll come back to that in a second. Okay, so product of a power means the outside power applies to every single piece on the inside. Okay, that's why the parentheses are necessary in that rule. Okay, the last rule I want you to be familiar with for this section is referred to as power of a power. Oops. Okay. And what this means is what happens when you have something that has an exponent, but then you give it another exponent, just like in the example we did right above, where I circled it with green. Okay. So the rule is this: when you have something that has a power, like x to the power of m, and what happens when you raise it to another power, let's say n. Okay, this is a power raised to a power. Okay, what this means is that you take these two powers and you actually multiply them together. So this would end up being x to the power of m times n. Okay. Now let's apply this to the example we did right above, right? So in the example above, we were left with this x power of 3 raised to another power of 3. Okay. What that means is that these two 3's, they actually get multiplied together. So this would simplify into x power of 9. And that's how you would simplify it. Okay. Now let's go back. Let's actually simplify the one above, where I circled it in green up here. So now that we know that rule, we can keep going with this, right? 4 to the power of 3, remember that's 4 times 4 times 4. Okay, a lot of mistakes will happen. A lot of students will go 4 times 3, and that would be wrong. Remember, 4 to the power of 3 is 4 times 4 times 4. If you need a calculator, use one, not a big deal. 4 times 4 gives you 16, and then 16 times 4, that'll give you 64. And then now we know what this rule says. When you have a power to a power, you multiply them together. So we have x power of 9, and then we have that y power of 3. That would be a complete answer to that question. Okay, that's why I said these two rules sometimes kind of intertwine together occasionally. A lot of times you'll see a question that involves both of these rules. Okay, let's do one question together. It's a little more complicated, so you can see exactly what's happening. So let's go with 3x power of 3, y power of -2, and z power of 5. All of it raised to a power of 2. Okay. Now, if you're looking at it, there's a couple things should stand out. I'm going to use a highlighter for the different things. So one thing that should stand out is you do have a power on the outside, right? That means that everything, the power on the outside has to apply to every single piece on the inside. So we can get to that as well. There's also probably the negative exponent that should stand out. Okay. However, in this case, you probably want to deal with the outside piece first. You can't really mess with the inside until you deal with that power on the outside. So let's actually start off, let's deal with this power of 2. So when it's on the outside like that, it applies to every single piece on the inside. Okay, so it applies to the 3, it applies to the x's, it applies to the y's, it applies to the z's. Okay, now I'm going to write it out completely. Okay, so we have 3 gets its own power of 2. Okay, then the x power of 3 gets its own power of 2. Notice I'm using the parentheses just as an organizational tool. Okay, then the y power of -2 gets its own power of 2. And finally, the z power of 5 gets its own power of 2. So every individual piece got its own power of 2, including the coefficient, the number up front, that 3. Okay, now we can go through, we can simplify. Remember, we have another rule here. When you have power to a power, that means you're multiplying. Okay, so let's go ahead and take care of these. So power to a power, power to a power, and power to a power. Okay, first the 3 squared, we can deal with that too. 3 times 3 gives you 9. Okay, then the x's. You had power of 3 raised to power of 2 when you multiply. So 3 times 2, you get 6. Then go to the y's. Power to a power, so -2 times 2 gives you -4. And now the z's, 5 times 2 gives you 10. Okay, we're still not done because we still have to take care of that negative exponent. Remember, you can't leave a negative exponent as part of your answer. So remember, you have to remember from the previous video, the rule for negative exponents is that that value has to switch sides, right? So let's go ahead and make this a fraction. Okay, and then to simplify it, that y term is going to move. So that y term is going to go down below y power of, now it's +4. Everything else stays where it is. So 9x power of 6, z power of 10. Okay, and now just do one quick double check. Make sure there's nothing else we can combine, which is true. X's can't mix with z's, we can't mix with y's. So this would be your final answer. Okay. All right. These questions are a little bit challenging off the bat, but as we do more, it will get easier for you. The more you try, the more you're gonna do better with. So next few days we are going to be doing some questions in class. So make sure if you are struggling, make sure you guys reach out, and I'll gladly help you guys out.